Okay, so here for this question, we have the height of the ball is given t seconds after it is thrown by the model h of, sorry, can you not count out? Is 1.5 plus 23t minus 4.9t squared, where 8 is the height of the ball in meters. Write down the height of the ball at the time it is released. What do we do first in problem solving question? Always. Sketch. Sketch the problem. So your first step, in order to start understanding this, is always to sketch the problem. So we go into our calculator, we press tab, we can scroll up and remove that one. I don't know why I pressed that. We can delete, actually let me just press on, new, no, calculator, add page. I think that's quicker. So let's type in the function 1.5 plus 23x minus 4.9x squared. Notice I've done a variable substitution of x for t. Because I want to put it on the axes, and our axes are determined in y and x, not y and t. We draw it. We want to see it a little better. So we're going to change our window settings. So here on the window settings, menu, window settings, the x minimum is going to be 0. So the x value is t, is time. What is the shortest amount of time that the ball is thrown? 0. We can't have negative values. It makes no sense with this. I saw on the graph that that's a little wide. I can shorten that a little bit. Also, what is the minimum height that the ball can have? 0. So we can reduce these ones down, and I think that needed to go a little bit higher. So let's try that. Ooh, higher still. So it's looking good. Graph, window settings. Make this 6 tab, but I need to make my Y maximum much bigger. Let's go up to 50 this time. There we go. We see the shape of the graph. So we've sketched the problem. This will do for us. Write down the height of the ball at the time it is released from the thrower's hand. So what is the time when the ball is released from the thrower's hand? 0. You can see that this is going to be the y-intercept constant. So the answer is going to be 1.5. But you can calculate this, trace graph. So 0 is the x value or the t value when the ball is thrown. At the beginning, we press enter twice and we get 0.1.5. So our answer here on this one would be f of 0 is equal to 1.5. And that is a height of meters. Find the number of seconds it takes the ball to reach the ground. So what is the height of the ball when it reaches the ground? 0. The y value or the x value? The y value. So hopefully we can still capture this. Okay, so what I'm getting here, it's not letting me find the 0 because I put my y minimum as a 0. So I'll just go back into the window settings and change my y minimum to -1 so I can see either side there. Then I'll try and find the 0. So we're trying to find when f of x is equal to 0. This gives us the answer. X is equal to 4.76. What's the units here? Ooh, let me just fix that. This function is defined in t. This is f of t is equal to 0, and this gives us t is equal to 4.76 seconds. Find the length of time the ball is higher than 16 meters. So 16 meters, is that an x value or a y value? What makes you say that? Because it's talking about height. It's talking about height, which is a y value. So on the graph, what we want to do for this one is press tab and enter in 16 meters. So we're finding the amount of time it's above this height. The amount of time it's above this height. We can do this by using analyze graph and finding the intersection. So we scroll backwards here, click, click, we got one, menu, analyze graph, intersection, click, no, click, click. So these are our two values. So for C, we want to find the difference between these two, don't we? We want to find the length of the line segment between them. So we're going to take the larger value, which is 3.94, and we're going to subtract 0.75, and this will be our answer. So we need 3.94 minus 0.75, which is 3.19. What is the units of this? What are we talking about here? We're talking about time, the units is seconds. And we're finished.